Okay, so I made a system of 3 variables, 3 equations, and the first thing I want to do is take my coefficients and put them in a matrix. So the professor uses like large parentheses. I use actual brackets when I do mine. So the first column is my x's. So here I have 3x, so 3. And then I'm not putting my operators in my equal signs, I'm just taking the coefficients. So 3 and then 2 don't have a z. And then the next equation I have 3, 2, and then 1. So that's my y's, that's my z's. So I have 2 x's, 1 y, and 3 z's. And I'm multiplying my coefficient matrix by my variable matrix, x, y, z. So I just had that there for reference. So I'm multiplying this, and when I do, I get 13, 13, and 9. So this is another way of writing this system. Sometimes it's called answer matrix, kind of whatever. So when you solve these, so the next thing you're going to do is augment the coefficient matrix and your answer matrix. So by augment, I mean like you take this column and you just stick it inside the matrix. And so instead of being a 3 by 3, it becomes a 3 by 4 because that's an extra column. So 3, 3, 2, 2, 2, 1, 0, 1, 3, 13, 13, 9. And then from here, I need to do my row operations. So with the row operations, you want to start by getting a 0 here. And then a 0 there. And then a 0 here. And then you'll have your diagonal, your pivot points, and then you'll have a lower triangle of zeros. And then you can start getting your upper triangle of zeros. And then here, and then last here. Okay, so I'm going to write it over clean. And there's something special about the first and the second row. It's almost the same exact number except there's a 0 and a 1. So that should tell you something very obvious about one of the entries of the solution vector. So one of the easiest things is 3, 3, 2, 2, 13, 13. I'm going to subtract the first and second rows. So R1 minus R2. And I'm going to place that in R2. So the first row stays the same, the third row stays the same. The only thing that's changing is my second row. So those copy. So 3 minus 3 is 0, 2 minus 2 is 0, 0 minus 1 is -1, 13 minus 13 is 0. And notice I needed that lower diagonal of 0, or the lower triangle of zeros. Well, I have 2 zeros and a pivot point. Well, that needs to be my pivot point when I move it. So I'm going to exchange R2 and R3. So I need those zeros on the bottom. So shorthand R2 and then the arrow facing both ways R3. And then 2, 1, 3, 9, 0, 0, -1, 0. And we can always scale the rows by a number. If you look at the bottom row, I have 0, 0, -1, 0. So I can just say that's a +1 because I'm not affecting the signs of zeros, and 0 is a number that does not have a sign. It's not positive or negative. And then I can worry about some other things. So I just need a 0 where that 2 is. So I'm going to multiply the first row by 2, the second row by 3, and subtract. So 2R1 minus 3R2, and I'm going to place that into R2. So I'm not really changing, because I'm placing it into R2, so I'm not really changing row 1. I'm just taking the entries and multiplying them by 2. But I'm not actually changing the matrix, and R3 stays the same. So 2 times 3 minus 3 times 2, that's 6 minus 6, that's 0. And then 2 times 2 minus 3 times 1, that'd be 4 minus 3 is 1. And then 0 times 2, that's 0, minus -3, or minus 3 times 3, that's -9. And then 2 times 13 is 26, minus 3 times 9, that's be 26 minus 27, so that's -1. And so I have my lower diagonal. And I have a 0 here, so I just have 2 more row operations, and I should be looking at my answer. So now I need a 0 where the -9 is. So my bottom row is what I'm going to use, because there's only one non-zero entry, and it's right in the column that I need it to be in. So I'm going to say R2 minus, because they're opposite sign, no, wait. Yeah, no, let's be plus. Because they're opposite in sign, I want to add, so they cancel. So R2 plus 9 R3, and I'm going to place that into R2. So R1 stays the same. R3 stays the same. Now I have -9 plus 9, 0. -1 plus 0, it's -1. And so the last 2 lines are solved for. The only thing left, I have a number here, I need a 0 there. And so I have one more step, and then I can look at maybe scaling the first row, and then I'll have my reduced row echelon form of the matrix.